Hi everyone, the question is, let x, y, z be positive integers such that HCF of x, y, z equal to 1 and x square plus y square equal to 2z square. Which of the following statements are true? Statement 1, 4 divides x or 4 divides y. Statement 2, 3 divides x plus y or 3 divides x minus y. Statement 3, 5 divides z times x square minus y square. And these are the four options. A, B, C, D, which suggests 1 and 2 only are correct, 2 and 3 only are true, 2 only is true, 3 only is true. These are the four options and we have to choose exactly one of these four options which is correct. Here I would like to point out, like in statement 1 and statement 2, it says 4 divides x or 4 divides y, 3 divides x plus y or 3 divides x minus y. So when this OR is there, even if one of these two statements which are connected by OR is true, then this whole statement becomes true. Yeah. Only if both these statements connected by this word OR, if both these statements are false, then only this overall statement is false. Now coming to the statement 1, 4 divides x or 4 divides y. Just by looking at it and thinking a bit, you can easily see that this is supposed to be false, because it is not necessary that x or y, that means at least one of x or y, should be divisible by 4. What to speak of divisible by 4, they may not even be divisible by 2. That means we can have, as you can see and think intuitively, we can have x and y both being odd, and odd square is odd square is odd. That means x square and y square both would be odd, given that x and y, if we take them as odd, and their sum would be even, which is on right hand side 2z square, which is even, which makes sense. And there should be such a possibility where you have x square plus y square equal to 2z square, where x, y, z are positive integers. To convince yourself, you may want to come up with a quick example involving some small x, y, z numbers, where again we are saying x and y are odd. So if you think a bit, you would realize that if you take x to be 1 and y to be 7, so you have what, x square plus y square equal to 1 plus 49, which is 50, which is essentially 2 times 5 square. That means z is 5. So clearly here x or y, they are not divisible by 4. So that means the statement 1 is not true, or you may say it is false. Now coming to statement 2, if you see carefully, out of x and y, if both are divisible by 3, then even z would be divisible by 3. If let's say x and y both are of the form 3k, that means x square plus y square is of the form 3k. I am talking about the form. Yeah, here definitely x and y may not have the same k, for both of them. That means x can be 3k1 and y can be 3k2, where k1 and k2 are different natural numbers. So here, nonetheless, if x and y both are of the form 3k, then x square plus y square would be of the form 3k. And for it to be equal to right hand side 2z square, that means z should be of the form 3k. But here, with this, there is contradiction. What is the contradiction? It is already given to us that highest common factor HCF of x, y, z is 1. That means x, y, z are they are, as a set, they are co-prime. But here you have x, y, z having the common factor 3, and HCF would not be 1. So there is contradiction with respect to WRT, means with respect to HCF information given to us. So that means x and y either both would be of the form 3k plus 1, or both would be of the form 3k minus 1, or one may be of the form 3k plus 1 and other may be of the form 3k minus 1. Yeah, makes sense. And of course there are other possibilities, being one being of the form 3k plus 1 and other being of the form 3k. So here if you see carefully, when both are of the form 3k plus 1, you would have x minus y being divisible by 3. Similarly, if both are of the form 3k minus 1, again you would have x minus y being divisible by 3. And if one is of the form 3k plus 1 and other is of the form 3k minus 1, then you would have x plus y is divisible by 3. So till here it seems that the statement 2 is correct. But what about this other possibility, that one is of the form 3k and other is of the form 3k plus 1 or 3k minus 1? Now here, if you see carefully, square of the form 3k plus 1 or 3k minus 1 will be of the form 3k plus 1. Check it out. Whether you square a number which is of the form 3k plus 1 or square a number whose form is of this type 3k minus 1, the square would be of the form 3k plus 1. Yeah. And what about square of of a number which is of the form 3k? It will be of the form 3k only. So that means left hand side, which is x square plus y square, will be of the form 3k plus 1 effectively. Yeah, it will be of the form 3k plus 1. Yeah. But what about right hand side? Right hand side would be of the form 2 times 3k, because if z is of the form 3k, then z square would be of the form 3k, and right hand side is 2z square, so it will be of the form 3k. And if z is of the form 3k plus 1 or 3k minus 1, then z square will be of the form 3k plus 1, and since on right hand side it is 2z square, so you can say it will be 2 times you may say 3k plus 1. So this is effectively, you may say, of the form 3k plus 2, or you may say it is of the form 3k minus 1, which is same thing. In both these cases, right hand side doesn't match with the form on left hand side. So that means this possibility that one of these x or y is of the form 3k plus 1 or 3k minus 1, and other being of the form 3k, it is not even possible. So that means whatever can possibly be possible, in all those cases, x minus y is divisible by 3 or x plus y is divisible by 3. So that means you can say the statement 2 turns out to be true. Now coming to statement 3, 5 divides z times x square minus y square. So again we can say that x and y can either be of the form 5k, or they can be of the form 5k plus minus 1, or they can be of the form 5k plus minus 2. That's it. So here x square and y square, I mean whatever the respective forms of x and y are, x square, y square, in this case would be of the form 5k, in this case would be of the form 5k plus 1, and in this case would be of the form, you may say 5k plus 4, which is the same as you may say 5k minus 1, isn't it? Now here one possibility is what? X and y are of the form 5k. That means what? X square plus y square would be of the form 5k. And since right hand side is 2z square, and if equality is supposed to hold, z square should be carrying the factor 5. That means z should be of the form 5k, which is are not possible, which is contradiction, because this HCF is supposed to be 1. If x, y, and z all are of the form 5k, then the HCF would not be 1. It would be at least 5. Yeah. So this gets rejected. So that means now the other possibilities are another possibility is, you may say x square let's say is of the form 5k, x square is of the form, let's say, 5k, and y square is of the form 5k plus minus 1. Yeah. So we have taken one possibility when both x square and y square are of the form 5k, which is contradiction to what information is provided to us. Another possibility we are taking, let's say one of them is of the form 5k and another is of the form either 5k plus 1 or 5k minus 1. Yeah. So what about left hand side? Left hand side would be of the form 5k plus minus 1. Yeah. And what are the possible forms of right hand side? Yeah, right hand side, one possibility is it is of the form 2 times 5k, if z square is of the form 5k, which essentially means form is 5k. Or another possibility is 2 times if z square is of the form 5k plus minus 1, then effectively the form on the right hand side is 5k plus minus 2. Clearly that left hand side form doesn't match with right hand side form in any possibility here. Yeah, because left hand side would be of the form either 5k plus 1 or 5k minus 1, but right hand side is of the form either 5k or 5k plus 2 or 5k minus 2. So that means even this possibility gets rejected where one of these two, x square and y square, is of the form 5k and other is of the form 5k plus minus 1. So only one possibility now remains, that x square and y square both are of the form 5k plus minus 1. So among this, a few possibilities are both are of the form you may say 5k plus 1, or both are of the form 5k minus 1. So you may say both are of the form 5k plus 1, or both are of the form 5k minus 1. And clearly in this case, you would have x square minus y square is divisible by 5. Yeah. There is another possibility where one is of the form 5k plus 1 and other is of the form 5k minus 1. Yeah. In which case you would have left hand side x square plus y square would be of the form 5k plus 1 plus 5k minus 1, x square and y square they add and they give you the form 5k. That means what? Since right hand side is 2z square, and left hand side is of the form 5k, 2 does not have factor of 5. So that means z square should have factor of 5. That means what? Z should be of the form 5k. Yeah. So here you can clearly see in this case z is divisible by 5. Z is divisible by 5. So either x square minus y square is divisible by 5 or z is divisible by 5. So that means even this statement 3 is true. So that means B is the correct answer. Only statement 2 and statement 3 are true. Thanks for listening. Stay tuned.